A very incredible good morning to everyone. This is Prakriti Shrivastava from class 11th. I am a student of LPM Public School, Gola Bazar, Gorakhpur, standing in front of you all to present my topic, that is hydrogen spectrum. Hydrogen spectrum. When at low pressure electric current is passed through discharge tube, then radiations are emitted. And when these radiations are passed through prism, then a large number of spectral lines are released and on the photographic plate, like here. This is discharge tube where the hydrogen gas are filled, and and here the electric current is passed. This is hydrogen gas. And so when electric current is passed through it at low pressure, then firstly some radiations are emitted, and then these radiations are passed through a slit, and then these radiations, some transmitted radiation, are passed through prism, and they get deflected and received on the photographic plate. And these numbers are so large that some scientists group together this series in different group these lines in different series in different regions. Like this is photographic plate, then these number of lines are formed, and scientists group them together in multiple regions, like that if they are the spectral lines, then these series are grouped together in visible region by Lyman. These series are grouped together by Bauman in a visible region, and these series are grouped together by partial bracket and P1 in IR region, means infrared region. So this is hydrogen spectrum. Now we move to, but there is a question in our mind, why only hydrogen spectrum produces large number of spectral lines. So to answer this, we know that hydrogen has only one electron in their valence shell, and so it is in ground state. So when it moves from ground state to a higher energy level, then there is a transition of electrons from lower energy level to higher energy level. But in higher energy level, it does not stay for a long time because there it is not more stable. So it come back again to ground state, and there so he takes so multiple jumps, and that's why the number of lines are produced. So there is also a question, how do we calculate the number of spectral lines? So to calculate the number of spectral lines, first of all, Balmer give the formula to calculate the wave number for their region, which is as 109,677. This is the constant number upon 1 upon 2 square minus 1 upon n2 square, and 2 here is the excited state. Here 2 is fixed because in Balmer region the ground state is always 2, so the ground state number 2 is always fixed. But this is not enough for all the series to calculate their wave number. So the second scientist is Rydberg, who in 1890 give his formula to calculate the wave number and wavelength both of the multiple series, and that is like 10967 into z square 1 upon n1 square, which is ground state region, and 1 upon n2 square means higher ground state excited state. Here this is Rydberg constant, which is denoted as RH, and this is atomic number. This